freefall lab, you're going to examine objects of different mass and of similar mass falling freely to the Earth's surface. This means that the only force acting on them is their weight. However, you will have a chance to turn on air resistance and see what happens when air is a factor. So in the last module, you learned about constant velocity and constant acceleration. Constant velocity means that you're traveling at you're changing your distance by the same amount every instant in time. Where constant acceleration means that you're changing your speed by the same amount every instant in time. The best example of constant acceleration is an object in free fall. When an object falls to Earth, the only force acting on them is their weight, because air drag is negligible. Then that object will fall at a constant acceleration of 9.8 meters per second every second. That means that they'll pick up their speed by roughly 10 meters per second every second. In the first activity, you will learn that mass really doesn't have much to do with free fall. You'll be able to look at two different massed objects, and when you press go or drop, you'll see that the 10 kilogram and the 50 kilogram really do not have a difference in any of their velocities or their times. One thing to note is that you can transfer the data collected on the right-hand side by clicking the Transfer Data button, and you don't have to type all that in. It just automatically dumps it in, and then you can answer questions. However, when you do turn on air, there is a difference, because once again, now you have you do have air acting on this, and so instead of just one force pulling down on it, you have an upward force of air acting on it, which slows down its acceleration. So if we look at this example, you'll see that although they both have the same mass, they have very different experiences. The mass that has air drag on it is going to fall at a less speed than the mass that didn't have air drag. So you'll get to explore that in more detail. And the other thing you're going to look at is when there is no air drag on, you're going to look at what happens when you drop things of different sizes to the distance and the speed every instant in time. Because they're picking up speed, they should fall a different distance each instant in time. So if you press drop here and you watch this 10 kilogram box, you notice that although it's picking up the same amount of speed every instant in time, right? It's picking up the same speed every instant in time. It is going further and further every instant in time. And that's because after 1 second, it's traveling at 10 meters per second. But after 2 seconds, it's traveling at 20 meters per second, so it can go further each time. So you're going to look at that relationship between distance traveled every instant, which should be getting bigger and bigger, and the velocity of every instant, which should be staying, getting bigger by the same amount every instant in time, whereas the distance increases by a different amount every instant in time. So that's basically what this is all about. And then you'll wrap this up by talking about terminal velocity, which is kind of a big topic, and explains why in every day we don't really experience objects falling in the same amount of time, because terminal velocity is a big issue. Because in the real world there is air drag and it does slow things down. I will talk to you later. Email me if you have questions.